Hello everybody, getting ready to do Chapter 7, Part 3, SAT Math Level 2 Prep. And for today's lesson, you got 12 points in your notebook guide, 16 points on your classwork sheet, name, date, period, and then due date here for onliners. Page 1 of today's lesson is there are a few trigonometric identities you must know for the Level 2 Math subject test. Reciprocal identities. Recognize the definitional relationships of cosecant x equals 1 over sine x. Secant x will equal 1 over cosine x. Cotan x will equal 1 over tan x. And then cofunction identities. These were discussed earlier. And if you're not sure on these, get one of my trig packets. Using radian measure, sine x will equal cosine of pi over 2 minus x, and cosine x will equal the sine of pi over 2 minus x. Secant x will equal the cosecant of pi over 2 minus x, and cosecant x will equal the secant of pi over 2 minus x. These are all cofunction identities. And then tan x will equal cotan of pi over 2 minus x, and then the cotan x will equal tan of pi over 2 minus x. Pythagorean identities. Sine squared x plus cosine squared x equals 1. Secant squared x equals 1 plus tan squared x. Cosecant squared x will equal 1 plus cotan squared x. Then double angle formulas. Sine 2x will equal 2 times sine x cosine x. Then cosine 2x will equal cosine squared x minus sine squared x, which will in turn become 2 cosine squared x minus 1, which will finally become 1 minus 2 sine squared x. You should know these identities and double angle formulas. If you don't, again, I can provide packets for you to study up. P. Let's try one. Given cosine theta equals negative 2/3 and pi squared is less than theta less than pi, find sine 2 theta. Okay, since sine 2 theta equals 2 sine theta cosine theta, you need to determine the value of sine theta. From this figure here, you can see that sine theta would equal the square root of 5 over 3. So sine theta here would be the square root of 5 over 3. And then sine 2 theta would equal 2 times square root of 5 over 3 multiplied by negative 2 over 3. And then this would come out to be in negative 4/9 times the square root of 5. So there again is our cosine here. You may be expected to solve trigonometric equations on the Level 2 Mathematics subject test by using your graphing calculator and getting answers that are decimal approximations. To solve any equation, enter each side of the equation into a function, y to the n, graph both functions, and find the points of intersection on the indicated domain by choosing a window. So to get to that, Q here, if cosine 23 degrees equals z, find the value of cosine 46 degrees in terms of z. So since 46 equals 2 times 23, a double angle formula can be used. Cosine 2a would equal 2 times cosine squared a minus 1. Substituting 23 degrees for a, cosine 46 equals cosine 2 times 23 degrees equals 2 times cosine squared 23 degrees minus 1. And that will become 2 times cosine 23 degrees squared minus 1 will equal 2 times z squared minus 1. In terms of z. Then R, if sine x equals A, find cosine 2x in terms of A. So using the identity cosine 2x equals 1 minus 2 times sine squared x, you get cosine 2x equals 1 minus 2a squared. And then S, solve 2 sine x plus cosine 2x equals 2 sine squared x minus 1 for 0 less than or equal to x, 0 x less than or equal to 2 pi. So enter 2 sine x plus cosine 2x into y1 and 2 times sine squared x minus 1 into y2. Set your x min at 0, x max equals 2 pi, and then your y min equals -4, and y max equals 4. Solutions, or the x coordinates of intersection points, are 1.57, 3.67, and 5.76. That should come up on your calculator. And then t, find the values of x on the interval of 0 pi for which cosine x is less than sine 2x. So enter each side of the inequality into a function, graph both, and find the values of x where the graph of cosine x lies beneath the graph of sine 2x, 0.52 less than or equal to x less than 1.57, or 2.62 less than the x less than 3.14. That would be your solution for this question up here. If the graph of any trig function f of x is reflected about the line y equals x, the graph of the inverse relation of that trig function is the result. Since all trig functions are periodic, graphs of their inverses are not graphs of functions. The domain of a trig function needs to be limited to one period so that the range values are achieved exactly once. The inverse of the restricted sine function is the inverse sine. The inverse of the restricted cosine function is the inverse cosine, and so forth. Okay, so the inverse trig function, let's go through that here. The inverse trig function, domain, and range. So we have the inverse sine here. Domain is -1, 1. Then range would be -pi/2 and pi/2. Then inverse cosine would be -1, 1. The range would be 0 and pi. And then the inverse tan would be infinity and infinity. Then -pi/2 would be your range. And then the inverse cotan would be a -infinity, infinity, and your range would be 0 and pi. And then the inverse secant would be the negative infinity to -1 in union with 1 and then infinity. And then your range would be 0 to pi/2 in union with pi/2 and pi. And then cosecant, the inverse of cosecant would be -infinity, -1 in union with 1 and infinity. And then this in turn would be your range would be -pi/2, 0 in union with 0 and pi/2. The inverse trig functions are used to represent angles with known trig values. If you know that the tangent of an angle is 8/9, but you do not know the degree measure or radian measure of the angle, the inverse tan of 8/9 is an expression that represents the angle between -pi/2 and pi/2, whose tangent is 8/9. You can use your graphing calculator to find the degrees or radian measure of an inverse trig. So again, if you need brush up on trig, get my trig packets. You here evaluate the radian measure of the inverse of tan 8/9. So enter second tan 8/9 with your calculator in radian mode to get 0.73 radian for that. And then V here, evaluate the degree measure of inverse sine 0.8759. So enter second sine 0.8759 with your calculator in degree mode to get 61.15 degrees. And then for W, evaluate the degree measure of inverse secant 3.4735. First define x equals inverse secant 3.4735. If secant x equals 3.4735, then cosine x would equal 1 over 3.4735. Therefore, enter second cosine 1 over 3.4735 with your calculator in degree mode to get 73.27 degrees. And then x here, evaluate cosine inverse cosine 0.72. So that will be just, these will cancel each other out, just be 0.72. And then y, evaluate inverse sine, sine 265 degrees. Enter second inverse sine, sine 265 with your calculator in degree mode to get negative 85. This is because negative 85 degrees is in the required range of negative 90 to 90. And negative 85 degrees has the same reference angle as 265. And Z here, evaluate sine of inverse cosine 3 over 5. So let x equals inverse cosine 3 over 5 in this situation here. Then cosine x will equal 3 over 5, and x is in the first quadrant. See the figure, use the Pythagorean identity, sine squared x plus cosine squared x equals 1, and the fact that x is in the first quadrant to get sine x equals the square root of 1 minus cosine squared x equals 16 over 25, radical of 16 over 25, which equals 4 over 5. And finally here we go into AA, evaluate the inverse cotan of negative 5.2418. So let x equal inverse cotan negative 5.2418, then cotan x will equal negative 5.2418, and tan x will equal negative of 1 over 5.2418. Enter inverse tan of negative 1 over 5.248, and it will return negative 0.1885. This value is in the range of inverse tan. And so it will return negative 0.1885. This value is in the range of inverse tan. So it is in this range, negative pi over 2 and pi over 2. But it is not in the range of the inverse cotan, which is 0 pi. Since cotan x is less than 0, x must be between pi over 2 and pi and have the same reference angle as negative 0.1885. Therefore, x equals negative 0.1885 plus pi, which is 2.953. This is not an issue with sine and cosecant because they have the same ranges as do the cosine and secant. Thus, the calculator output for similar problems involving cosecant and secant would be correct. And that is your part 3 of Chapter 7, SAT Math Level 2 Prep, animated PowerPoint math video at AOL.com for course materials or questions. Thank you very much.